Hey everyone, ever just stare at the moon? It's kind of crazy, like we think we've got it all figured out,
Yeah.
and then bam, science throws us a curveball. Speaking of curveballs, we're diving into an article from December 22nd this year. It's called, Did Earth's Gravity Give the Moon a Volcanic Makeover? Ooh, catchy title, huh? It's about a theory that basically says the moon might have had a total facelift billions of years ago. A facelift that could mean it's way older than we thought.
You hit the nail on the head. This theory really shakes up how we think about space. We tend to think of things like the moon as just there, frozen in time. But this research suggests it had a wild and fiery past.
Oh yeah, for sure. We learned in school that the moon formed about 4.35 billion years ago from this huge collision between Earth and a Mars-sized object. The Apollo missions brought back lunar rocks that seem to back that up, but now scientists are saying those rocks might be misleading, like they're just the surface layer, and underneath could be a much older moon.
Exactly. The problem is that 4.35 billion years ago, that's about 200 million years after the solar system started forming. And by then, pretty much all the loose material had already clumped together to form planets. So a giant impact like that so late in the game.
Well, it just doesn't fit with what we know about how solar systems evolve.
Okay, so that makes sense. There's a timeline issue. So how do they explain that? What's this whole lunar facelift thing about?
It all comes down to something called tidal heating, basically. In its early days, the moon was much closer to Earth, and Earth's gravity was like constantly pulling and stretching the moon's insides, creating a ton of friction. And that friction generated massive amounts of heat.
Whoa! So like a cosmic deep tissue massage, but on a planetary scale.
You got it. And all that heat had to go somewhere, leading to, you guessed it,
Volcanoes.
volcanoes on the moon. Seriously.
Not just a few eruptions here and there. We're talking about potentially global-scale volcanic activity. Eruptions so powerful they could have completely reshaped the lunar surface.
That's wild. Is there any evidence of this kind of thing happening anywhere else, like in our solar system?
Yeah, actually, there's a great example. Jupiter's moon, Io. It's the most volcanically active place we know of. And it's all thanks to tidal heating from Jupiter's immense gravity.
So if this happened on the moon, would that mean all the rocks we've been dating are actually way younger than the moon itself?
That's the key idea. If this massive resurfacing event took place, it would have basically reset the clock on those surface rocks.
Making the moon look younger than it really is.
Precisely.
Okay, I'm
Yeah.
sad to get it. So that also helps explain why the moon doesn't have as many impact craters as we'd expect for something its age right. A volcanic facelift would have erased all those early impacts.
Exactly. Plus, there's this other intriguing piece of the puzzle. Some scientists have found lunar zircon crystals that date back to 4.51 billion years old. And that's even older than the current accepted age of the moon.
So hold on, we've got this timeline problem. This mind-blowing theory about tidal heating and volcanic resurfacing. And then these ancient zircons throwing even more fuel on the fire. It's starting to sound like a full-blown lunar mystery. What happens next? How do scientists figure this out?
Well, luckily, China's Chang'e 6 mission just brought back samples from the far side of the moon. Analyzing those samples could give us some clues. Either support this theory or maybe point us in a different direction.
So we could actually be on the verge of rewriting the moon's history books.
It's definitely possible. And even if this particular theory turns out to be wrong, it shows us just how much we still don't know about the moon and about the early solar system.
And that's what makes these deep dives so cool. It's not just about the moon itself. It's about the whole intricate dance between the Earth and the moon and how they shaped each other over billions of years.
I completely agree. It really makes you appreciate the interconnectedness of everything out there.
Totally. If the moon really formed earlier than we thought, it means Earth was dealing with this giant space neighbor way earlier in its own history.
Imagine that. A young Earth with a massive moon hanging in the sky.
What would that have done to Earth's early oceans? The tides must have been insane.
Oh, absolutely. The moon's gravity is the main reason we have tides. And if it was closer to Earth back then, those tides would have been way more extreme.
Whoa. So we're talking about ancient coastlines constantly being reshaped by these super tides. What about Earth's rotation?
That's another thing to consider. The moon's gravity slowly slows down Earth's spin. That's why our days are getting longer over time. And a closer moon would have sped up that process.
Meaning Earth's early days might have been much shorter than we thought.
You got it.
It's mind-blowing how connected these two bodies are and how much we're still learning about their shared journey.
It's a constant reminder that there's always more to discover.
Absolutely. Who knows what other secrets the moon is hiding? Let's keep digging and see what else we can uncover.
You know, it's funny to think. If this new timeline for the moon is right, it could change how we see the whole solar system.
How so?
Well, we use the moon as a kind of reference point when studying other planets and moons. So if we're wrong about the moon's history, it throws everything else into question.
Right. Like using a wonky ruler to measure everything.
Exactly.
So let's just assume for a second that this theory about the moon being older and having this volcanic makeover, let's say that's all true. How would that change our view of the moon itself?
Well, the biggest thing is, it means the early moon was way more active and volatile than we thought. Instead of this calm, unchanging orb, it was a world in constant upheaval.
I can't even imagine. We always see the moon as this peaceful, silvery disk.
I know, right? But billions of years ago, it might have been covered in lava flows and erupting volcanoes.
That's insane. I wonder if there are any other crazy secrets hidden beneath its surface.
Actually, that brings up a really interesting point. Some scientists believe that during these periods of intense volcanic activity, the moon might have actually had an atmosphere and even liquid water on its surface.
Wait a minute. Are you saying there could have been life on the moon?
It's definitely a possibility. Now, those conditions probably didn't last very long, but it's not impossible that some basic life forms could have emerged.
Wow. So the moon wasn't always this barren wasteland we see today.
Exactly. It's a reminder that we should never underestimate the universe's ability to surprise us.
Okay, so we've talked about what this means for the moon, but what about Earth? How would an older, more active moon have affected our planet?
Well, we already touched on the tides, but an earlier, closer moon would have made them even more extreme.
So think massive tides.
Yeah, much stronger than anything we see today. Those tides would have carved out coastlines and influenced where marine life could survive.
And the moon's gravity also slows down Earth's rotation, right?
Right, so an earlier, closer moon would have had a bigger impact on that, meaning Earth's early days were probably much shorter than we think.
That's crazy to think about. Shorter days, different tides. Must have been a totally different world back then.
It's incredible how interconnected these two bodies are, and how even small changes in their relationship can have huge consequences.
So we're not just learning about the moon. We're learning about the history of our entire planetary system.
Exactly.
And if this lunar facelift theory is right, that history might be a lot longer and more dramatic than we ever imagined.
It definitely adds another layer of mystery to our cosmic neighbor, and it challenges us to rethink everything we thought we knew.
Okay, so we've covered some pretty mind-blowing possibilities here. But science is all about testing those possibilities, right? So let's shift gears a bit and talk about some of the arguments against this theory. Where's the healthy skepticism?
Yeah, I mean, not everyone's going to be convinced right away. Right. No, not at all. In fact, a healthy dose of skepticism is what makes science work. It forces us to keep asking tough questions and look for better evidence.
So what are some of the challenges facing this whole tidal heating idea? Why are some scientists hesitant to jump on board?
Well, one of the big things is the moon's orbit. To create enough tidal heating to melt the whole surface, the moon had to be much closer to Earth than it is now, but not too close, or the tidal forces would have ripped it apart completely.
Okay, it's like a cosmic balancing act.
Exactly. And trying to recreate those exact orbital conditions in computer simulations, it's not easy. We're talking about incredibly complex gravitational interactions billions of years ago.
So even though we know tidal heating happens, we're not sure if it could have happened on the moon in just the right way to cause this facelift.
Right.
What else are scientists looking at?
Those ancient zircons we talked about, they're definitely old, but their chemical makeup is just as important. Scientists are analyzing them to see if their composition matches what we'd expect from a period of intense tidal heating and volcanism.
So it's not just about how old they are, it's about what they're made of and what that tells us about the environment they formed in.
Precisely.
So what's the next step? What kind of research will give us some more definitive answers?
Well, the samples from China's Change 6 mission are a good place to start. Comparing them to the Apollo samples could tell us a lot. Finding signs of ancient volcanic activity in those new samples would be a big step towards proving this theory.
What about the computer simulations? Can we improve those to test this idea?
Yeah, definitely. Scientists are always working on better models that can simulate the Earth-Moon system more accurately.
So it sounds like we're in for some exciting times in lunar research. New data, better simulations, new analytical tools, all helping us understand the moon better than ever before.
Exactly. It's a really cool time to be studying the moon.
It's amazing to think that something we see in the sky every night still holds so many mysteries.
Absolutely, and that's what makes science so fascinating. It's a never-ending quest for knowledge. We're always learning new things and challenging our understanding of the universe.
It's a good reminder that there's still a sense of wonder out there, even in the things we think we know best. So next time you look up at the moon, take a moment to appreciate its beauty and all the secrets it might be hiding. And if you want to learn more about this lunar mystery, check out the links in the show notes. Thanks for joining us on this deep dive. And until next time, keep looking up.